Right, well, I'm back. Sorry about that, I'll have to get things all booted up again and get it all running again. It's all a bit of a mess right now. Try and get my chat window and everything all open again as well. I'm dropping heaps of packets still. This is really struggling. Just give us a second, I'll try and get this thing going. It's just not behaving. This bit rate's getting lower and lower. I might have to reduce my resolution to 720p. It's struggling to keep up with 1080. Okay, we'll see how we go with that. Live streaming on wireless. Yeah, it's great fun. At least it doesn't take long to restart the computer. Well, let's get this bloody thing back to where it was supposed to be. Adjustments. Where are they? Adjustments. There. Where are we up to? Let's go football, done that one. I think. Yes. We're on A5 now, aren't we? Yeah, it's a bit of a disaster having bloody stream dropping off, but I think it's under control now. Hopefully the quality is good enough still. I've had to drop the stream rate right down to 1800. Which is quite low for 1080p. It's supposed to be 3000, so I don't know how it's going to work out. Alright, so let's see if we can get this up and going again so we can see what we're doing. So we've just done the offset 2, hadn't we? No, we're doing the offset 2. Okay, so we'll get this here. Make it big enough so you can read it, hopefully. That's too big. Okay, here we go. Right. 6 people watching, hopefully everybody else gets back. Yeah, so the stream's all going again, that's all good. Only barely going. Anyway. So where are we? So TP2, I'm hooked up to TP2. And so we've got to be, it didn't say anything about what the other parameters are, so it's capacitance and parallel mode. So nothing between the unknown terminals, so okay, open terminals. High terminals and low terminals respectively must be connected together. In other words, it's got the external sensing terminals that need to be connected together. So then we need to do this. A5R40 offset 2 DC level based upon, well, 0 volts. Okay, let's zoom this up. It's got the same thing there. That is fairly well centered. That's not bad. I might just leave that there. There's 2 millivolts of division I'm looking at it right now, not 5 millivolts. We'll go to 1 millivolt if you want. There you go. That just shows, yeah, that's well within spec, because if it is plus or minus 2 millivolts, it'll be off the screen. So that's fine. I think people watching, that's concerning. There's only 3 people watching. What happened to everybody else? Is it all gone? Yeah, need to look at this. Alright, so that seems to be in spec. Offset 3 is the next part. The stream showing up. Okay, hopefully it comes right. Cool. Right, yes. Having problems with the stream, it's not behaving very well. If I make this quality I'm watching mine stream at really low, that might help too. Which I don't need to watch my own stream, I can just pause that and it'll help too. Everything I can do to get the bandwidth up, it's going to be good. Yeah, right, I think we're back okay. So we keep an eye on this drop packets and stuff. It's still dropping down a bit. Right, well, so there we go. This I think is a bit too big. I need to bring it down slightly. Get a size in between us two, don't I? 250%. Yeah, that's better. Alright. Probably got 300%. Yeah, nah. Alright. Okay, so I'm going to go on to TP3. I need to find. It's over there. It's got some interesting waveforms going on there. Okay, so what we've got to do here. 50 millivolts. Test signal, alright. So 50 millivolts per division. Well, I'm on 2 volts per division right now. And I'm going to get an offset correct there as well. But you can see what it's doing, can't you? Apart from something weird. So I want 50 millivolts per division. So if you compare this to the diagrams on the manual, it's a bit different because it's triggering quickly enough. The one on the manual, you can see the vertical lines where it's got a very big sine wave going through it, and obviously this is fast enough to be able to just ignore that. So yeah, it's seeing the individual bits. Anyway, we'll just bring it up a little bit. So you want to adjust what? R54 offset 3. I can see offset 3 there. That's cool. I'll try and bring this up a bit. That's a bit hard to get the average when it's a waveform in itself. If I bring this out a bit, you can see a bit more about what it's doing. There you go. So you see it's pretty noisy. After roll mode, it's just, yeah. Anyway, it is looking like it's kind of centered. I mean, if you look at that waveform there, as jittery as it is, it's around that point, but it's got to be plus or minus 10 millivolts. Yeah, that's pretty hard to get judged on there. So originally it was, what was it, 500 microvolts of vision, wasn't it? The original setting. Pretty hard to judge that. Let's, what are we looking for? Let's increase the memory depth. Let's drop down a bit, that might help slightly. And persistence of 1 second to create some averaging. It's just a mess, isn't it, really? It looks about right. Yeah, they don't make this one easy to bloody do they? That persistence is really not helping. I mean, it's close. I think it's close enough to be okay. Cool. People are gradually coming back. Yes, that's gradually. I mean, it's so hard to judge because if I was using an analog scope, it'd probably be easy. Because then you get that waveform they've got up there. So, 0.5 milliseconds of vision, yeah, which is what I've got, and 50 millivolts. Well, I'm on 100 millivolts right now. Because just look at it. But yeah. Anyway, triggering can be a pain sometimes. That looks pretty close. I think this is one I've already done. So I've already done these adjustments. I was playing around with it before, trying to do troubleshooting. So we'll move on. I think those are okay. So there is actually one more adjustment there which we haven't touched yet, which I think we come back to later on. So let's have a look. So what to do next thing is the A6 board. So we'll set this up. So 1 kilohertz. Oh, jumped pages. So 1 kilohertz. Yep. DC bias off. 1 volt signal level. Internal trigger inductance mode. Series. Range hold off. Okay. Unknown terminal shorted together. Let's drop it down before I do some damage to it or something. Where's that program? Here we go. That lead. Short them together, and then we want what's this point? Okay, got to set the slide switch to test 2, which is fine. Range hold on. I just said to turn it off. Doesn't miss the page, is it? No, okay, I think it might be right. So, switch, test 2. And range hold on at any time apparently. No, I'll do it there then. And offset full pot, which is the last one on that board. Let's take this off here. I think we're looking at that right now. This in its mid position. Okay. So I've got to do adjust offset 0 or 0 offset for 1000 plus or minus 2 counts on the LCR display. So I'll pop this up again so you can see it. Hopefully. Yes, this is live. Watch out for mistakes, there's bound to be some. So now I've got to see what that thing is. R68 on the A6 board. So that's one of those. Zero offset and two. What's that one there? APAO. So I think it's this one here I need to do. Yep, there we go. Here's that one. So I can set it to 1000. Try and get it well in. There we go, about there. Right. There's in spec anyway before I even adjusted it. So you've got to do phase offset, which is R67. Which one is that? Just make sure there's not another one down here which I can't see. Yeah, I think it's just that one there. Right there. I see it myself now. So this should be able to set to 0 plus or minus 2 counts. So yeah, that's still right adjustment, alright. Can I go less than 0? It's interesting. Okay. For 0 to 2 counts. Wasn't 1. Trying to do that, so it's just tricking because I don't think it likes to go minus. Anyway, so that's okay. Reset, switch to normal. Done. So we want capacitance next. Parallel. Range hold off. Connect to 10 NF standard capacitor. Ah. I don't have a 10 NF standard capacitor. I will have a 10 NF capacitor. I might have to do some comparative checks to get something close to that. This is where it gets a bit tricky. Yeah, this is a bit I'm going to have a problem with because I don't have a standard capacitor which HP specified. Let's read this a bit more carefully. Yeah. Well, on those adjustments I just did, 67, 68, I mean I just adjusted those. Or is that just like a zeroing before you get to that part? So then you got to do them for this. Tricky bit, eh? Tricky. So I might need to go and find a 10 NF capacitor, an accurate 10 NF capacitor. You might have to wait a little while I go and do that, I'm afraid. I don't have any intermission music, I'm afraid. I haven't got any. I've got some caps here, but no, I need. Yeah, I've got no. I haven't got any 10 NFs in here. I need to go and get one from out of the house, which I'll need to find. Then it's not going to be a standard capacitor, so it may not be the correct calibration value. I can do the section part here. I could just try doing that bit and just leave the first part and see how we go. It may mess up the calibration, but yeah. Right, because I do have my test box here, which I can plug, which I can set for 100k. So we shall do that. We'll skip that bit there. We'll go to this one, and I'll have to figure out what I'm going to do with the rest later on. So you want 100k, like so. Now, what I'll do is I'll also hook this up to my Siglant, and I'll get an actual value from this. So if I know what the actual value is first, then I can set it to that, rather than assuming it's exactly 100k. Obviously 2Y measurement's not perfect, but so it's 100.63. Check for any dirty switches, can be an issue on these things. So 100.63 is what the Siglant reckons it is. So that's what I'll aim for on here. Makes sense, doesn't it? So we'll give that a tweak. My Siglant's a 6.5 digit counter. It does have capacitance mode on it as well, so yes, I can do capacitance tests on that. I also have my DER 5000 as well as a few other testers, but the DER I trust and the Siglant I trust for capacitance. They seem to correlate quite closely together, so I don't mind just getting a value and checking it for that. So because it's looking for a D value, I don't know what the D value is going to be on a capacitor which is specified. So capacitance value, yeah, sure, I could set it to that, but not D value. The dissipation factor, I just don't know. Again, that's an area I'm not particularly strong on, to be honest. So right, we'll look at this adjustment here. So AR68, which was the zero offset, which was there again, and we'll give that a tweak and see if that comes right. So we go to 0.6. Okay. So let's whack this up to, so that's 900, it's like 10k out on here. Let's see what the Siglant thinks of that. $894. No, now it's saying 902. What's it's that initial bit? So the Siglant is, you know, more accurate in that regard. Make sure it's tight. So this is out by a little bit on here, which is a little bit interesting. That may require some further investigation. There's a little bit of jumping around in there. There could be an issue still present. Could be. Anyway, we'll move on. And then 1K again. Right, A5. Oh, jump back a bit. Back to the A5 board again. It's a final adjustment, which we zeroed previously, or centered previously. So A6 TP3 with the scope. A6 TP3 is where? That one there. Get it hooked on, it'd be good. And we'll stick this on a convenient shield. Simon still is, he dropped off participants. Show. Can't see who's actually watching. That Simon's still there. He's probably gone to bed by now. Okay, so there was that. done that section there, so that's what we want to do. So 1 kHz, bias off, 50 millivolts, internal trigger, capacitance, parallel, yeah, range hold off. So what to do about these, does it? Did it say what to do about those? I didn't see what it said about open terminals. Did it say anything about those? Might have gone past it. Right, well, doesn't say what to do about the terminals. Whether you leave them open or what. That's a bit interesting. Well, okay. So, half a volt we reckons. 50 milliseconds of division. That's jumping all over the place. Let's take these out. Does it help? Yeah, it does. I'll take those out. So it was 50 milliseconds of division. Okay. Got a pretty big DC offset there. So I've got to set that trimmer we set before for center position to 0 it, which is this one here. So it's supposed to be plus or minus 1 volt. So that's well within there. So that trimmer's in a different place to what it was before, so that's actually improvement, I think. Right. That might be the procedure done. Confirmation check, chuck a cap on. Yeah. Right, well, we'll give it a go. Without being able to set the dissipation factor properly, because I know the reference capacitor, it could be a bit interesting. So, take this off. So we want a capacitor chuck on there. I want clip leads, which I have lost again. How do I keep losing those clip leads? It's incredible. They're right in front of me. Right. Next paragraph. Yeah. Well, I was working through it. We'll just go through. So it wants a 1000 PF cap. Well, I've got a 100 PF cap. Which will have to be done in serial mode, I think. Is that 100 PF? Yeah, it is 100 PF cap. Oh, what I... So it's jumping around a little bit. Why does that sound stable now? Wasn't it unstable before? Is this worse? Okay. As long as I've got it set on 1 volt in parallel mode, then it reads okay. Accuracy? Yeah, don't know about that, but so it shows together then. Yeah, I'm going to have to look into this in a bit more detail. Well, I can't check dissipation because I don't know what the dissipation actually is unless I just base it on my DER 5000 values. Let's just zoom this out slightly. Oh, get the right window. I think that's actually the end of that procedure there, isn't it? Yes, it is. So I'll just get a capacitor, check at the DER 5000 and do a comparison. We'll do that, eh? Let's do a comparative check and see how that comes out. Try and get this so you can see it as well. Be helpful. Did it work? Not well, but it works, kind of. Oh, let's get this cap here, which is a big one. I've got a few caps I could try it on, so we'll try a few different ones. I might get some short test leads for this. I will have some here somewhere I can use. Okay, so according to this DER, hopefully you can see that. Not well, is it? Does that kind of work? Yeah, it works. So that's 230 UF, 0.385 dissipation at 1 kHz. So I'll try 1 kHz first. Bit different, isn't it? That's quite a bit different. Yeah, it has been serial mode. Oh, sorry, 1 kHz. Get the frequency right. So it's 426 on this one. So there is a difference there. 233. $231, 368. So there's an error there. Which one is wrong? So we'll try change the frequency. Let's go to 120 Hertz on this one. So that's 238 and 0.057. This one's much closer, 238 and 0.064. So that's a much closer reading. We'll try another one. I'll try a much smaller capacitor, shall I? Let's see. This is pretty small. See what this does for it. Little 10 UF. So it's 0.04 with 9 UF there. .04 with 9 UF, those actually agree. So it's looking pretty promising, isn't it? Let's try a higher frequency. This should be completely wacky, I expect. So it's 8.7, 0.15 thereabouts. 8.7, 0.15. Those match. So that's pretty good. Let's try a much larger capacitor. Let's try a 10,000 UF. I think this might struggle with actually. Oh, yeah, I'll do it on 120 Hertz now. 120 Hertz. Can it read it? Yes, it can. So that's 9.7 millifarads. So, well, no, it's 8.9 now. It's settling down. So it's 8.9 and 0.09, almost 0.1. So this is very different. This is correct. I should have some serious mode anyway, shouldn't affect it. So yeah, I don't know. It's I'm suspicious about that a little bit. Why it's got such a different reading. This probe's not the best fit either, that's probably not helping. Yeah, a little bit suspicious. But it seems on the lower range it's definitely okay. That's, I needed one of standard capacitors really, don't I, to test that properly. Right, let's try another one. Let's try a really crappy 100 UF. This is a poor quality brand. It's a Suntan, and we'll probably call it for this. So that's 120 Hertz. It's 103 UF, 0.03 dissipation. On 3 UF, 0.03 dissipation. So, you know, it seems on the smaller capacitors at least it's fine. It's the bigger ones which are showing a difference between this. So you need another standard to see what's actually going on, don't you? 2 meters is never enough. You always need 3. Okay. So how are we going? Still I'm sitting back in this chair now. I can see the chat again. Nothing's been said for a little while. So, do you think there's a problem with that dissipation factor? I don't think I've got any other way of measuring it. I don't think the sigilant measures dissipation, it only does capacitance. Pretty sure. Should have a look, shouldn't I? No, that's not right. No. No, it's not going to show me anything other than that. I don't think I'll do that. No. I think it's all this guys, it's capacitance. I don't think it does dissipation, anything like that. Right. So, as you can see, it's at least working. You know, it's close. But it seems the higher ranges might have issues. You know, the resistance one's showing up quite a bit, in 10k out at 900. That's a big error. So, you know, it's that's not that big, is it? It's about 1%. 1% out. I would not be surprised that the HP unit is okay. You think that's fine, dear? Do you reckon that's alright? I mean, anything else, the lower ranges seem fine. They seem accurate enough from what I can see. I don't have any inductors in here to test. don't think. I've got a transformer. I suppose I can measure that, couldn't I? Let's do that. Measure transformer. So this multi-tap transformer sitting here, which is conveniently sitting there. We'll measure the upper side, shall we? Secondary. We'll just go across those two there. Should be a small winding. Let's see what this thing thinks. 627 microhenry. Right. See, that's very different, isn't it? Mind you, that's at 1 kilohertz, I think. So because it's effectively inductance you're measuring, aren't you? So it's going to be, yeah, it's inductance. It's, of course, it's inductance. Bloody hell. So 676, which is closer. What did I say that was? 600 and what? .648. So yeah, that's very close. 1 kilohertz. Let's do 120 hertz. That's 730. 729. That one is very different. That's significantly different, isn't it? Let's try it across the full winding. Let's go across the full winding. 15 volt winding. So that says what, 18.8 millihenries. Can't decide who's going to do series or parallel. And still can't decide. There we go, 23. Yeah, dodgy connection. Yeah. So close-ish. Let's get this thing out again. I'll do a comparison on this one as well. I don't know if you get to see it, that's the only thing. So I'll do it across the full winding with this one. I need to zero inductance first, don't I? Zero this thing first before I do that. I don't know what frequency this test at, so it's doing 808. So that could be a 1 kilohertz test. So yeah, might leave that alone for now. Okay, so what do we do now? This thing seems to be fixed. Well, I've got an idea of what to show you next. If I get the stuff back in the drawer, it'll be good. The drawer's a bit full. Oh my god, come on, get in there. It's a bit ridiculous, really. Okay. Trying to get it all in there. Too much test gear. Actually, that's not true. You can never have too much test gear. Okay, turn it off. We'll be back to chat. Let's have a look. Yeah, okay. I'll agree with that helmet, I suppose. I mean, the HP's, you know, got a lot more gear in it than the DI5000 has for a start. So which one do you trust though? I mean, but when you got, if I had 3 meters, I could then use the third one to give me an idea which one's the furthest out. I don't like to just rely on 2. I always like to have 3. That way you got a better idea. But then, you know, there's no guarantees in with 3, but it gives you an idea if one's vastly different from the other. So, okay, well, stream is kind of behaving. It's not the best. It's still dropping frames, but it's not doing too bad from what I can see. So we're pretty good there. So I'm happy with that. The unit seems to be working, at least, you know, as well as I can test it. So I think I'll close it off there. Now I'm going to show you something else which I haven't even powered up yet, so you're going to see it powered up for the first time. It could go bang. It could go bang. Let's get this out of the way, make some space, and then we'll look at that. This piece of gear is featured on the mailbag. I've shown on the mailbag, but that's as far as it got. I haven't done anything else with it yet. I've only just put a plug on it so I can actually plug it in. So it could be exciting. Could be. I've got to change the voltage selection on it yet, so get the iron going because it's a soldered selection. Having a cable hanger, really handy. Keeps things tidy quite nicely. Right, let's move this that way. Okay. Almost at a point where I can use a desk again. I shall leave these going because who knows, I might need them. Right. Item of interest is this. So I think I'll hide that top window now. Get it out of the way. Oh, yeah, I'll do this instead. I shall turn that one off. There we go. And zoom this one in some more for you so you can see. Hopefully a bit better. Okay, I should do, shouldn't I? I'll still keep the scope in there. Right. So this is a A161B DC current source. Now this did feature in the mailbag when I got it. So I believe it's all good. And I haven't actually done anything with it. I've got no idea how to use it yet. I haven't read the manual. Haven't done anything. The power cord for it, it's a special cord. It's got this proprietary 3-pin plug that goes on there, like this. So it's a bit of a pain. So I had to cut the plug off. It was on originally, one of these. Cut that off this morning, put this plug on. Haven't done any testing whatsoever. Put this back down again before I plug it in, before I forget. So obviously I've taken the covers off because I need to change the voltage selection around because it's currently set for 115 volts. So it's got jumpers on here. I need to change these jumpers around. I need to put a jumper between these terminals here and take the other ones off apparently. So we need to get onto that. So I have to keep popping over the other side to chat. I can't see very well from over here. So we'll take those jumpers off first and then add the third one on. Where did I put my tweezers? There they are. I need those. Yeah, I'm still using the knockoff Heiko. It's, well, the fake Heiko. As it's pointed out to me by someone, I can't think who it was now. Knockoff is also meant for stolen. In the UK, it's a, you know, Yeah, I suppose. I mean, I'm from the UK myself, obviously, right? But I've heard it used in both contexts, so I don't really associate the two. But anyway, we'll get this off here. Hopefully. Actually, if I do the other one, I might be able to link them across that way using the same piece. That looks like it's through the terminals, actually. That might be tricky. That's a lot of mess there. This is an opportunity to try a new tip out, isn't it? Can I get out with this? Yes, I can. Oh, that's annoying. Let's shut it off for now. Let's get them a tip. I've got these new tips here, which I haven't tried yet. Let's get a bigger tip, because I'm going to need that. Which size do I want? Yeah, let's just go a couple up. One go all the way up. We'll see if this breaks it again. Last time I pulled the tip out and put it back in, it broke it. Nah, all good. Alright. No, it's complaining. Right now? Yeah. That's a bit better. Okay, we'll heat mass in that. I might have to increase the temperature as well. No, let's go. Can I pull that off? Is it actually? I think it's actually through the holes inside the tabs. Okay, I'm going to be cutting those wires then. I'm not going to be getting those off in a hurry. That tip is a bit dodgy. It's jumping around a bit. Let's just these tweezers aren't the best thing messing with this. Need like a proper gripper thing. No. No. Seems okay now. Just dodgy connection. That's why you don't buy fake stuff. You just buy the original. Look, I bought this because Louis Rossman was mentioning about this particular unit being a good investment because it's cheap and it gets you away from the other style of iron. You know, so the older style where it's got the ceramic bit in the head, you got the unscrewing sheath and a separate tip and. You know, the old style iron, and with these being superior styles, and I agree with that after having used them. But this iron, this particular one, not a good investment. I didn't buy it because he said it's a good investment. I bought it because I wanted to see if it was a good investment. I was skeptical about was it $80 or $90 iron being any good. I think I was right. It's not very good. It's the handle which lets it down. This piece seems okay. I mean, it had that little earthing issue. If you haven't seen a review I did on this, go back and check it. I had an earthing issue in here, which I corrected. That's not a big deal. But most of the issues I had was the handle and bad connections in the handle, because the connectors inside are just too thin and too weak. They're bending too easily, and it's just not very good. Right, so let's cut these. I'm waffling again. I'm getting a bit sidetracked here. Probably waiting for me to get this thing powered up. Wait for the smoke. I actually don't like the fact that you got exposed mains terminals, because that's what these will be, aren't they? These will be mains terminals from the transformer. Yeah, so that's the socket there, straight to here. Exposed mains terminals, right there, which you can touch. And if the bottom cover gets dented in, which is likely to happen because it's so, you know, because it's being perforated like this, that could short out. That's not the best thing, is it? It's a bit concerning. Really want that to happen, would you? Right. Well, I need to get a bit of wire. basically. So I'm supposed to go between, let's say, 2 and 3. Yeah, so just between there and there. That's fine. So I should do it. Chat's awfully quiet, guys. Not saying very much. Just waiting patiently for the smoke, aren't you? It's not the best wire, this actually. It does take solder, but it takes a little bit. Come on. Oh, a nice solder joint on there. Not only get a nice solder joint on there. So we'll just get this going. I'm not going to do too much testing on it. I'm just going to see if it powers up okay or not, and if it goes bang. And after I've done that, I'll cut the stream off. I've got some other things I need to get done today. Right, so that's on there. Not well, but it's on there. Let's plug it in and see if it goes bang. My camera moved, hasn't it? It's dropped down a little bit. Tends to do that. Right. Got this new mount on there which is really long, so it's a bit... Gravity takes its toll eventually. Okay, here we go. Plugs in. Let's turn it on. I'm nervous. We have indicators, we have activity on display, or on the meter. No bangs yet. Well, let's plug the meter in and see what it's doing. I need the cables back. Caution, high voltage. Really? I told him those and plugged them in. Let's find out. $14 volts, yeah, that's not really high voltage, is it? Just trying to get it back in shot properly. Yeah, 14 volts is all it will do. It's got a multi-turn pot for current. So there's a setting on here, just tip this up so you can see it. turn this light off, get rid of some glare. It's not the best. Do that. Bearing in mind there's live terminals right there. Can you see the meter there? It's looking a bit glary. Let's close this curtain a bit, eh? That might help slightly. Or not, I don't know. Is that any better or not? No, not really. Anyway. Yeah, you can kind of see the needle, I suppose. There you go, you can see it better there. So, has these different current ranges. You can turn your current up and down, multi-turn pot. So I suppose I could put this across a meter and see if I can see the current draw. Seems like a plan, doesn't it? If I run it as a current range. So it will go up to, say, about 28 or 0.28. Just on a scale there, so it's 28 milliamps there, and so on. But it's supposed to do 100 volts. I'm not seeing 100 volts out of it. So it looks like it does have a fault, because it's supposed to be able to do 100 volts. As you can see here, 0 to 100 volts. It's not doing that, it's only doing about 14. So it does have an issue. So let's chuck this on current and we'll see what we can get out of it. Turn it right down, don't want to stress it too much, and I'll wind it up a bit as we go. DC amps you want. Chuck it in there. Alright, let's see what we can get. Well, it is slowly coming up. Doesn't like to be loaded down at all though. That's turned all the way up, and I'm only getting, well, very little. Is that why? Voltage limit is on. That's 10 milliamps there, we're not seeing it. Oh, put that back on milliamps, that'd be helpful, wouldn't it? Here we go. Right, and current. So what I'm seeing on here is not matching what I'm getting on there. So it should be doing 2 milliamps right now, and that's not what it's doing. Just go and read the comments, I can't see. Yeah, it does need something on those terminals to cover those up and make them safe. Who knows, I might see me zap myself yet. Yeah, that's through an RCD. Everything in here is through RCD, so that should be fine. But not an isolating transformer. But yeah, what you're seeing here isn't what we're seeing there, which is interesting. So let's go next range up, 25 milliamps. Showing us 30 on there. So yeah, this needs some loving, alright. No doubt about that. So let's 250 milliamps go. Which means that's times 10, so it'd be 50. That should be 50, getting 70. That should be 100. I'm getting 100 there. That one lines up, so first one it has. 150. Pretty close. 200. again close, a bit low. 250. Still doing, well, still struggling to get up to 200. Yeah, it's relative to that voltage I'm trying to set as well. So I think that the this voltage issue is what's causing the problem there. Yeah. So yes, this is going to be a project for a future video, obviously, because currently it's not working right. So it's probably going to be a case of recapping it and going from there and checking transistors and things like that. So that's a nice future project. We get to look forward to that. Let's unplug this thing before I kill myself. Alright. But as you can see, it's got some old caps in here, some sprags, another one there. It's got some adjustments in there too. Might just be calibration maybe needed, but it'd need recapping certainly. You know, those are old. As far as anything being burnt, I don't see anything. Also, got these massive caps here, which I have to look at. Sprag as well. 400 UF, 100 volt. 400 UF, 100 volt. I've got some 470s. What voltage are these? That's 50 volt. So yeah, I might have to get some more. To buy some caps for that. But something like this. Let's get this out of the way. I hate proprietary connectors like that, but anyway. And it's just a shield under there, but it's all mounted onto. So looking at the bottom of the board there, maybe bad joints, maybe. Also got those big transistors here on the heatsink as well, so it could be one of those is gone. Entirely possible. And there's 4 of those on there. But I don't see anything actually blown, nothing obvious. So a little bit of dirt in there, a bit of crud, but yeah. Might just be a case of recapping it and that might do it, but we'll see. I suspect it's probably got blown transistors. Someone's probably shorted the output too much on a high voltage and killed it. Right, so I'm going to wrap the stream up here. A bit of a preview to something that's going to come up soon. Well, ish. Did I show you the Valhalla yet? I think I showed you the. In fact, I've got one. The it doesn't work above 300 volts. It cuts out. I think I might have shown it. I can't remember. So that's something which will feature at some point too. Right, guys, I'm going to cut the stream off here. I've got to go and do some things, and the weather's not helping my stream quality either. So thanks for watching, guys, and I'm not planning to do any more streams in the near future. Nothing's planned at the moment. We'll see how we go. I might just do some impromptu thing, but if I do streams, I'll try and do them in the mornings, so it seems that it's the best time for people to try and catch them. So thanks a lot for watching, and I'll catch you later. Bye.